Good morning, everyone. Hope you're well. Yeah, my name's Andy. I look after the UK side of the Fibre business for Sika. So thank you very much for joining this morning. Agenda for the next hour or so, a very, very brief intro to Sika. Then this has been designed for all levels of knowledge, to be fair. So there may be a little bit of egg sucking involved at the start as we look at concrete reinforcement, different types that we're interested in. Then we go into the fibre reinforced concrete side. We'll look at the different types of fibre that are available in Sika's portfolio. We look closely then into explosive spalling, which is quite hot topic at the moment, especially with the likes of HS2 tunneling, etc. There is a section on HPC guidance just to clarify kind of once and for all what isn't allowed on those structural block and beam floor toppings in the housing industry. There's a short section on metal decking, which is an area that Sika being the experts in steel fibres, we're really interested in pushing steel fibres into that market in particular. Section on best practice. We believe it's important to get things right from early concept right through to delivery on site. And then we get into the second section, the meteor section, which is on the new SikaFiber design software. So we'll get into that, see how it works, what it looks like, what it's capable of. There's a very quick cost comparison at the end, but it is quite the eye opener, to be fair. And then very short summary at the end, and as Aoife alluded to, a Q&A section to finish with. So Sika as a company, global, going since 1910, so 110 years plus, 25,000 employees globally, over 6 billion in sales last year, and they continue to grow. Important figure on there as well, nearly 190 million spent in investment in research and development last year. So very, very much at the forefront of technology. In terms of the UK footprint, head office for us is down at the lovely Welwyn Garden City. We've got an R&D facility over up in Preston. Over in Leeds, we have the Everbuild facilities where the products manufactured for the builders merchant side of things. Sika Silicants in tubes. Most of us will have used a Sika product or purchased a Sika product possibly without even realizing it. We've got an office over in Dublin, and then the new lab facility that everybody is excited about up in Wishaw. So, as I said, apologies for those that are obviously fully au fait with this, but concrete, use of reinforcement in concrete. Concrete obviously very, very strong in compression, but you spread that concrete load over a slab, it suddenly becomes very weak. So the all-important rebar has to be designed into concrete slabs as a tensioning device, taking care of those tensile forces. Maintaining the structural integrity, so leaving the slab with the ability to maintain the load and carry the load that it's been designed to carry post cracking. The important point there being that concrete with rebar will still crack. I still get plenty of comments from contractors saying, well, we always use rebar because it never cracks. The reality is that they're long gone by the time the concrete does actually crack. We're talking several months post installation. So steel rebar itself, it is big, it is bulky, 2.5 by 5 meters near enough is the standard size sheets that get delivered to site. The A grade steel mesh, so the 200 mil squares, that's the mesh that we're interested in. From the light crack control, the A142, down to the heavier structural 393, which can be a 2-man lift on site. This stuff is, as I said, it's big and heavy and bulky to handle on site in particular. The A obviously just means it's a square mesh, and the numbers mean the cross-sectional area of the wire. The point being, the A142 down to A393, that's where we can get involved and look at a potential fibre design. Fibre reinforced concrete. If you cast fibre reinforced concrete into a beam, put it through a beam testing rig, the image on the right is pretty much what it will end up looking like if you keep applying a load to it. The point being is that with fibres, the fundamental difference is the reinforcement goes through the entire depth of the slab. Very akin to steel rebar in that the fibres don't stop concrete from cracking, but what they will do is allow the concrete to maintain the loading, again, that it's been designed to carry even after the concrete's cracked. So Sika's fibre portfolio has grown extensively since late 2018 when Sika purchased Propex Concrete Systems. So Propex were Chattanooga based over in the US, but they were a global supplier of different types of fibres. So with the acquisition of Propex, Sika has become a fully fledged fibre manufacturer and supplier. So in their portfolio, microfibres very much run of the mill, to be fair, target applications, self-compacting concretes, particularly for the early age shrinkage cracking. That's pretty much the role of a microfiber, other than when it's used in explosive spalling, which I will touch on shortly. We also do a particular microfiber that's designed and works very, very well in dry sand cement screed, i.e. it doesn't ball up when it's mixed. On to macro fibers, the big brother really of the micro. It's still the same material, it's still polymer based, but we do have a macro fiber that carries a structural performance. So we can use our HPP 50 out of 4 kg per cubic meter dose, and we can demonstrate that that brings a residual strength to your concretes, particularly popular in external slabs, HTV areas, that kind of thing. Steel fibers. Steel are and will remain for quite some time the strongest of the fiber family in terms of sheer strength. Composite metal decking, which again, I'll touch on that shortly. That's an area that Sika in particular feel would benefit from growth within the UK. There's an estimated somewhere around 5% of concrete metal decks that are installed that use steel fiber instead of rebar. So there's a big target market for that. Power float floors, I mean, power floating and steel fibers go hand in hand, particularly we obviously recommend the use of a dry shake. Appreciate there are different schools of thought on that. That's purely our guidance. Jointless flooring. Jointless is a term, although it's industry recognised, I obviously feel it is slightly misleading. But we do have a steel fibre, a high tensile steel fibre that works very, very well in jointless floor design. So up to 40 by 40 metre panels, that kind of size. We can also look at pile design, so suspended floors, which may benefit from the use of a steel fibre. And more popular, again, Sika corporate in particular, very keen on the shotcrete and the tunneling industry. Just for information, actually the UK is now 3rd globally in terms of current tunneling projects in size and value, and that's just behind Japan and China. So tunneling in the UK, very, very much hot topic. Blended fibres is the last in the Sika range. We have a small number of bags of fibre where there's more than one type basically in the bag, offering more than one benefit. External paving, additional crack control. We have a great blended fibre that works very, very well in agricultural slabs, that kind of thing. And we have two fibres specifically designed for block and beam flooring, which again, I'll touch on under the NHPC section. So if we look a little bit more closely into microfibers, features and benefits, we touched on explosive spooling. There is a slide dedicated to that coming up next. The first 24 hours is pretty much the job of the microfiber. Outside of explosive spooling, microfibers, they will reduce settlement and bleeding. They will reduce plastic shrinkage. They, as I said, work particularly well in self-compacting concrete. Self-compacting concrete is high cement content, therefore it's high water content to allow that ready mix to flow. Obviously, the more water in the mix, the more moisture to leave the concrete, the more chance of that early age shrinkage cracking. Reduced freeze thaw damage. It does reduce the effect of freeze thaw damage in external paving concrete. They definitely don't, however, replace air entraining agent. They will add a small amount of air entraining effect to the concrete. That's purely based on the surfactant that's used to aid the mix dispersion, but they definitely don't replace air entraining agents. The non-magnetic, rust and alkali proof, and obviously it's a fibre, it goes throughout the depth of the concrete. There's no minimum cover to worry about. So if we look just a little bit more closely into explosive spalling, this is an area that is certainly gaining traction within the UK. HS2, London Power Tunnels, Woodsmith Mine, etc. The list is starting to grow. We have a microfiber under the Fibre Mesh brand 150F. This removes the risk of explosive spalling. It's a 32 micron diameter, which we believe, as does industry experts, that is the best micron diameter to use if you're looking for effective explosive spalling. Dosage, typically 1 to 2 kgs per cubic meter. We do a range, and we do a single kilogram bag, and we also do the large 280 kg bulk bags for all the fibre dispensing machines, which are often used on these types of projects. Proven track record we have, and we always recommend fire testing up front. Those of you that's witnessed the effect of explosive spalling, I'm sure that memory will be ingrained for a lifetime. It is quite a scary scenario to be involved with. On to the macro fibers. Touched on this earlier. We have a product, HPP 50, which is our premier macro fiber. The structural performance there at 4 kg. So effectively, we can take an external slab, maybe a couple of layers of A252, originally specified for HGV vehicle yard. We can remove both those layers, use our HPP 50 structural macro fiber at 4 kilos, and hopefully offer some sort of saving, especially given the recent increase in steel mesh. Flexural toughness, cohesion and reduced segregation. Again, this is important. What we're giving the contractor a chance to do is pour concrete without having to use a concrete pump as well. Trucks cannot drive over steel mesh, obviously. So any external slabs that are being poured tend to have to need a concrete pump as well if they're going down the traditional route using steel mesh. Impact and shatter resistance. I've seen this done. We did have a video which I'm hoping to be able to get to you at a later date. I'm struggling to get it to play on the slides, but it just demonstrates the sheer strength that these fibres bring to a concrete slab. They're polymer based, so they're completely chemically inert and rust proof. This makes them very popular with sea defense application as well. So if you want rust proof reinforcement basically for an application, anything external, HPP 50s at 4 kilos. If the use of a concrete pump is unavoidable, the concrete pump companies do tend to favor macro fibers as they don't tend to put as much strain on the concrete pumps and the pipes themselves. Obviously much safer and easier to use than traditional rebar. You've not got to carry the mesh, install the mesh, make sure it's in at the right height. Several gangs I've seen on site where it's just a complete trip hazard walking over steel mesh whilst you're trying to hold on to a concrete pump. And yeah, obviously the ultimate goal for us is to remove that need for the steel mesh. So with regards to the NHBC guidance, I in a former life actually worked for Propex Concrete Systems, and I was at Propex when the NHBC issued a statement that said microfibers would no longer be recognized as viable reinforcement on structural toppings for block and beam floors. Now, what the industry took from that was microfibers were banned, which wasn't actually what the NHBC was saying. They were saying you can use microfiber, but you have to use something else as well. And that created quite a bit of confusion for a number of years until it was finally bottomed out in January 2018. So the blocks used on block and beam floor, and we're just talking about block and beam floors on housing here. So the blocks used were divided into two grades, non-load bearing and load bearing. And the guidance is that a structural topping is required if the blocks are non-load bearing. A giveaway sign is when the blocks are the polystyrene type, you need a structural topping on there. The NHBC have said you can use a layer of steel mesh. However, given that these toppings are literally 75 mil thick, there's not a lot of wriggle room in there to install a layer of mesh. So you can use a approved steel fiber dosage or an approved macro fiber dosage. And we actually have both in our portfolio. So usually comes down to contractor preference, but we do have a solution to suit both requirements. And just quickly on there, structural toppings not required if it's already a load bearing block. So hopefully that clears up the block and beam scenario. Steel fibers, touched on this earlier. They bring an ultimate shear strength and impact resistance to the concrete. Abrasion resistance as well. That's quite important. I mean, as a loose rule of thumb, we tend to favour the macro products for external use and steel fibres for internal. Basically because the macros are rust proof. However, there are instances where scrap yards, for example, great application for steel fibres. They will improve the surface life of the concrete because of the abrasion resistance. You won't get that from steel mesh because obviously the steel mesh has got 50 mil or so cover on there. There is a very real opportunity to increase the loading capacity using a steel fiber dosage. Also, the important note on there is the potential to increase base sizes. Now, we'll touch on this in this fiber software section, but it is possible to use the steel fibers and design slabs beyond the traditional sort of 6 by 6 or 8 by 8 meters. And we can use we have a high tensile steel fiber that we put forward for design on suspended floors. Metal decking. This is an area Sika believe should be taking more advantage, particularly of using steel fiber. If you think of the general sort of areas where composite metal decking is used, they tend to be city centre builds, and city centre builds tend to have very, very small site footprints. So getting a flatbed wagon in there with these 2.5 by 5 meter sheets of steel mesh is getting increasingly more difficult and becoming more of a health and safety issue. So a steel fiber concrete for metal decking, it's not just about steel fiber versus traditional mesh in a cost sense. It's a very real installation buildability approach. So back in the day, Propex conducted fire testing with 2 decking manufacturers in the UK, one being Taurah, the other being CMF. So Propex paid for full-scale testing on these. So they constructed full-scale composite metal decks, basically cast them in concrete with steel fibers within the concrete, and then the fire tests were conducted. What that generated for Taurah and for CMF was then the fire rating, which drove the ultimate fiber dosage. And examples there for an hour fire rating, the fiber dosage 25 kilos, goes up to 2 hours and 35 kilos there. Best practice. Now, this is something that is very close to my heart, because I've seen and been in the situation where you've taken a tender project, a very early stage, you've put a value engineering solution forward for a fiber reinforced concrete instead of the traditional mesh, and then it gets contract awarded, gets to delivery onto site, and for whatever reason the fiber batching guidelines haven't been followed, and what arrives on site is the dreaded concrete with huge fiber balls within there. It is heartbreaking when you've done all the work early doors. So what Sika do, being the super risk averse company that they are, we produce several batching guidelines based around mixer and dry leg plants. The batching guidelines cover every fiber in the Sika fiber portfolio. They've always got health and safety in mind. We'll always maintain that it needs to be a safe addition of the fiber product. For example, using a conveyor for the steel fibers is very key to us. They are guidance documents. Whilst it says guidance only, if the concrete manufacturer follows the batching guidelines as they are, step by step, there will be no fiber balling issues. All concrete plants vary, appreciate that, but the guidelines are there for a reason. Similarly, and I've seen this happen all too often as well, you get everything right at the beginning, you get the concrete batch correctly, the fibers are mixed in beautifully at the plant, arrive on site. The floor finish responsibility does remain with the flooring contractor. So we do provide guidance on best practice for finishing techniques with fiber reinforced concrete, and this is very, very important. There are obviously several flooring contractors that use fiber concrete day in, day out. There are also flooring contractors that we're trying to bring on to start using fiber concrete more. And they're the ones that may require just a small amount of guidance, and it's just some simple tips and techniques that the flooring contractors can use on site and minimize any fibres at the surface. Touched on this earlier, steel fibres for power floating indoors. We always recommend the use of the dry shake. We don't insist. It is contractor preference generally, or it can be built into the engineer design. But we do have a range of products that can be used on steel fibre floors. Again, minimizing those fibres at the surface. We also have a range of specialist resins for finishing solutions as well, which may increase the properties, the finer properties of the hardened concrete. So onto the Fibre software itself. Now, this has been designed by Sika Corporate. Very, very, very exciting stuff. It's completely free to download. It's been created for engineer professionals in mind, for them or for you to produce your own designs completely offline. I'll touch on this again shortly, but it's completely designed with TR34 in mind, particularly when it comes to the safety factors. However, you have the option to go in and change those safety factors if you wish. We don't recommend it, but the system does allow you to do that. It also allows you to include a layer of steel mesh. If there's any areas in particular, I've seen fibre floor designs where 95% of the slab with a fibre design is sound, and then there's just a small area, could be a mezzanine, could be a heavy point load. For whatever reason, the software will allow you just to put some mesh in there, just to bump that area up. It looks very, very pretty as well with the 3D visuals. There is an online user manual, however, we do have a full separate software training online available that we can set up and deliver. So this is pretty much what the intro screen looks like. It's very straightforward. It's a step-by-step process. You start by adding the details about the project. As I said, you can go in and tinker about with the safety factors if you're confident enough to do so. Importantly as well, the K value, as it is now, the subgrade reaction, that needs to be input before you proceed. The option to include multiple load cases is great. For example, vehicle material handling equipment, you can put in the wheel data by contact area or by contact pressure. There's guidance graphics all the way through. And then you get to the check and design stage. So the concrete type of concrete is input, you C35, C40, etc. You select the SikaFiber that you intend to use from the drop-down box, put in the slab depth, specify the load transfer. That's something else that's more advanced from the old Propex software that we used to have. You didn't have the ability to specify the load transfer at the edges and the corners. And there, the section at the bottom where you can put that additional layer of rebar if required. I'm hoping you can, this is clear on your screens. The section on the right there gives you the check-in details. So anything that's failing will flag up as red. You can see there, obviously everything's nice and ticked and green. What we do have the option, or what you have the option of, is the wizard tool, which basically creates the most effective fiber design and dosage from there. So it will lock in the fiber type that you've chosen, but it will give you the optimal fiber dosage and slab thickness to achieve those loading details. So once your design's done, you can then go in and view the results. I mean, this bearing in mind this process is minutes, so you have all this at your disposal and very, very quick to go through and generate a design. The results checker is a lot more detailed than systems we've had in the past. Punching checks, pending checks, UDL checks, and it's very clever. It will go for worst case scenario, so it will always check. The whole fiber design will be based on the worst case, and then at the end it will roll out these. You can PDF print the reports and the calculations for review and for distribution. So benefits of the software: completely free and licensed. As I said, the calculations are done very, very quickly. It's almost in real time. It is very, very user friendly. Bearing in mind, I'm not an engineer. I can use the software. It is very easy to jump into and use. Multiple languages. As I said, it's been developed by Sika Corporate, so it is a global piece of software. When you do sign up, you do select that you're in the UK. The reason being is Sika operate in several different countries, and the fiber portfolios do change. So you make sure you're on the UK setting. You've got access to the full Sika UK fiber portfolio. Another benefit to this software is it will be maintained and up to date as things progress, as we develop new fibers and bring them on board, as we hopefully or potentially reduce our declarations of performance, for example, for particular fibers. All of that information will then feed into the system, so you'll always be designing slabs with the optimum fiber dosage. You've always got Sika's full technical support as well. So just to conclude, really, I mean, sort of why all the fuss to get fibers into concrete? This, I'm very pleased to say, is a job I was involved with. I want to say last year, but last year was written off. It was actually 2019. It was a project up in Buxton in Derbyshire. I received an inquiry from a local concrete producer that they were looking for 1,000 cubic meters of PAV2 just for an HGV yard. Ground conditions were solid, 200 mil slab depth. So I decided to do a little bit of a cost comparison at the time. So the original spec was a PAV2 air and train, which the concrete producer was going to charge £85 per cubic meter. Based on a 200 mil slab depth, that gave us the 5,000 square meter area in total. Now, again, the original spec was actually 2 layers of A393, possibly over-designed, which obviously would help our cause. At the time, that was at a cost of £3.50 per square meter. So just raw material cost, there's 1,000 cubic meters of concrete at £85 per cube, plus the £3.50 per square meter times 5,000 times 2, because there's 2 layers, so 35 grand in A393. So just as I said, raw material cost there, 120k, not including the labour, not including the concrete pump, not including the chairs, the spacers, etc., overlaps, wastage. It was just a very, very rough calculation to get an idea. Now, the fibre reinforced option, the base concrete remained the same as a PAV2, £85, but the concrete producer then charged an extra £25 per cubic meter just to put some 4 kilos of a structural macro fibre in there. The slab depth remained the same, 200 mil. However, we were able to remove the need for the 2 layers of the 393. So whilst the concrete itself had gone up to £110 per cubic meter, the mesh cost was completely removed. So just on a material basis only, there was a 10 grand saving. Now, I can also tell you that the original program for that was 5 days at 200 cubic meters per day. The contractor managed to do it in 4 days. Managed to pour 250 a day without having to use a concrete pump as well. And that's just on 1,000 cubic meter external yard. So potential is huge in terms of savings. So just to sum up, everyone, fibres, we will find a benefit to put fibres in any type of concrete, even if it's just microfiber for shrinkage control. Increased strength, durability, impact resistance, plastic shrinkage. Again, as these concretes get more advanced, the contractors and developers are favouring the self-compacting concretes in particular. But as I said, there is a potential for those to shrink much more than your conventional concrete. So the use of fibres in there to reduce that plastic shrinkage. We can, as we've demonstrated, remove the need for steel mesh. And Sika, having acquired Propex, they are very, very much a fully fledged fibre manufacturer and supplier now globally. You've got the full design and technical support from Sika on hand. There is so much knowledge within Sika. There's always someone available to help. Production training, I can't stress that enough. It's great getting all the technical side and the design done and passed and etc. But the production is just as key. It's just as important that these concretes get batched correctly. As I said, Sika, we are here at your disposal. We just want to help. Please, 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 just ask. And thank you very much, everyone. I believe Aoife's going to take back control and we can go into see if you guys have posted any questions.
Thank you very much, Andy. So just like he said, we're now heading into the Q&A portion of this session. The Q&A box is just on the right. So if you want to, we've already had a few people post questions in there, but if you've got any you'd like to ask, just type in your question there and we'll get to as many as we can. Obviously, any we don't cover today, we will come back to you separately via email. So without further ado, let's get started. So we've had one through, Andy, that says, can you use more than one fibre type in a design?
Yes, absolutely. External paving is probably the best example. The example I've literally just gave on the cost comparison, that was a macro fibre and a microfibre. So the macro fibre was in there structurally to take care of the loading, and the microfibre was in there for the additional crack control benefit. With it being an external slab, it's more susceptible to freeze thaw and greater temperature ranges, particularly with the wonderful climate that we get in the UK. So yes, 2 fibre types definitely is always an option.
Great. We've also had another one through that says, if I download your Fibre software, what's to stop Sika gaining insight to potential NGA projects at early stages?
So the software, the SikaFiber software, it downloads to your desktop. It's not used online. So what happens is if you're interested in using the software, it is completely free, but we send you a link to go into and sign up and basically request for the software to be downloaded. The software then downloads to your desktop and sits as just a little icon on your desktop. So when you're using the software, it is completely offline. Seeker's got no way of knowing what you're using it for. Any updates are installed every time basically when you log in initially. If there are updates required, it will do the updates sort of in the intro screen before you go in to use the software. So completely untraceable from our end.
Great. We've also had another one through that says, would there be any effect on water cement ratio on using SikaFiber in concrete?
Great question. I would say it depends on the concrete mix. What we can do is look into trials. We have done this in the past where we've looked at using fibres in watertight concrete mixes, for example, where the water cement ratio is very, very low, down at 0.45. So what I would say to that is, yes, there is a potential, but we would always look to do a trial mix beforehand.
Great. We've also had another one come through saying, what is Sika doing to mitigate the impact of producing micro and macro fibres?
Right, probably from a carbon footprint sort of view.
Yeah.
Okay. So our micro macro, they're produced at our facility in Chattanooga, in Tennessee, over in the US. They once a year carry out investigation into their CO2 footprint, and they are targeted to reduce that footprint year on year. Now, I think net carbon zero is unrealistic, to be fair. It's a polymer-based material. Even if they produced at net carbon zero, which isn't possible, you've then got obviously the transport costs of getting the fibres over to the UK. So yes, it is something that is very, very much on Sika's sustainability radar, and it is looked at year on year. With a view to reducing that CO2 footprint.
Great. I've just had another one through. It says, hi Andy, you talked about using microfibers for explosive spalling. Can you give any examples of projects you've been involved with?
Yes, there is a brochure actually that we have that I can share if required. But basically, we've got history with Crossrail back in the day with Propex, and today we've literally just started supply to a Pacadar project with their precast for HS2 concrete panels, which Hanson is supplying the concrete, I believe. So we're supplying Hanson with the microfiber for explosive spalling, and we've just completed successful trials with Stanton Bonner as well. So hopefully looking into another HS2 related project.
Great. Sorry, just bear with me 1 second. So we've just had another one through that says, with regards to composite metal decking, what drives the fibre dosage and exactly what testing needs to be done in that instance?
Well, the fibre dosage generally is driven by the fire rating. So every metal decking project will come with attached with a fire rating, and it's somewhere between an hour and 2 hours. That generally drives the dosage. However, the decking manufacturers that we're partnered with, so Taurah and CMF, they will give you access to their software to check local loadings if required. There has been instances where there's an area that contains a significant loading detail, for example, where they've either had to, again, use a layer of mesh as well as fibres, or they've put trough bars in to increase the tensile strength. But it's generally the fire rating that will drive the dosage. Testing that's been done, it was in the region of 90 to 100,000 pounds per deck that was done. So the Propex physically, along with Taurah and CMF, constructed metal decks, raised, cast concrete with steel fibre in there, then set fire to the deck and timed basically till structural failure, did the timing to ensure that the dosages were accurate.
Great. So we're going to just wrap up with one final question. Obviously, anything that hasn't been answered by Andy today, we will come back to you. So don't worry about that. Your questions will get answered. So the last one I've got here for today's session is a two-parter for you. It says, will the Fibre software always be free of charge, and is it kept up to date?
Okay. As far as I know, hand on heart, the Fibre software will always be free of charge. I mean, I don't see any benefit in Sika. Suddenly, Sika corporate will control it ultimately, but I don't see any benefit in Sika charging for this software because the fibres used within software are Sika's fibres. So the benefit will hopefully come to us to use the fibre anyway. So yeah, I would say that the software is always going to be free of charge. And sorry, could you just repeat the second part, please, Aoife?
The second part was, is it always kept up to date?
Yes. Okay. So the software is maintained by Sika Corporate globally. So we have our engineers over in Switzerland at head office constantly updating. And when I say updating, what they'll do is they'll update the FR1, FR4 values in the background. So as and when we bring on new fibers or we retest our existing portfolio, the FR1, FR4 values, so the residual strengths in there will be updated accordingly. And as I touched on, when you initially boot up the software, each time you boot it up, if there is a UK update required, it will do it as you sign in before you start using the software.
Fantastic. Thank you very much, Andy, for presenting and answering everyone's questions today. And thank you to everyone who joined us for spending the last almost an hour with us. We will send you out a follow-up email in the next few days, which will have a link to this webinar recording. And it will also provide a link to the software for you to download. We do have some post webinar survey questions which we would love for you to fill out as you leave the webinar, and it will redirect you then as well over to the software if you'd like to download it and give it a try. So thank you very much for your time, everybody, and we hope you have a lovely rest of your day. Thank you.